Okay, so we're going to briefly go straight into our data visualization in R. Just to recap again, once you have your data in front of you, you want to follow a systematic pattern in analyzing that data. If you followed all through the course of this training, we've identified 6 steps of data management process. The first step we said was to explore the data. The second step we said was to clean the data. The third step we said was to manipulate the data. The fourth step we said was to describe and summarize the data. The fifth step we said was to visualize the data. And then the sixth step is the analyze data. So we're in the fifth step today, which is visualize data. Now, we're working in the Tidyverse environment. So we've installed and loaded our Tidyverse by using the install.packages and then using the Tidyverse in brackets and in quotes. And then you load it by using library in brackets Tidyverse. So having done that, we'll jump right into our data visualization. So when you're visualizing data in R, some group of people have decoded a simplified way to apply graphics of data in R, and it's called the grammar of graphics. The grammar of graphics. And once you can understand the underlying principles in the grammar of graphics, you can do anything regarding visualization in R. Once you understand that underlying grammar of graphics principles. And so I would urge us to just pay particular attention as I try to explain what the grammar of graphics is and relate with the principles. So now I'm going to expand my source window. Okay, blah, 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 blah. Good. Okay, so the grammar of graphics has 3 basic steps that you use to apply the grammar of graphics in R. Now, it's been shown summarily that whatever graph that you want to plot regarding data has 3 basic components. One is the data from which you are producing that graphical representation, the data. Number 2 is the mapping. Now, when I say mapping means the coordinate space on which you apply your geometry or your graphical representation. For example, the Y and the X axis. That's the mapping, like the canvas, like the layer on which you do your painting. That's what the mapping means. And then the third component is the geometry, which is now actually that graphics that you put on the canvas. So it can be a bar chart, it can be a histogram, it can be a box plot, it can be a density plot. So all those things are now what we refer to as the geometry. So let me go over it again. You have number 1, the data, which is where you get all the values which you use in plotting your graph. Number 2 is the mapping, and the mapping is the coordinate space or the canvas on which you apply your graph. And then the third component is the geometry, which is the actual object that you use to describe that data, which could be your bar chart, your histogram, and all that. So if you understand these 3 basic components of the grammar of graphics, there is no graph that you cannot draw in R. So I'm just going to go ahead and help us appreciate that. Okay, so Now, since we're working in R gives us the privilege of having different data sets that we can use freely to practice our work. And one of those data sets is the BOD. Now, when you want to see all the data sets that are available in R, all you need to do is to type data and then click Control Enter, and then it will give you, for example, if we do this, this is data here that I just highlighted. If I click Control Enter, it gives us basically all the data sets within this package that we can use to practice. And you can use any one of them to practice. Now, the one we're using to practice for today is this BOD, which is biochemical oxygen demand. We don't really need to know the details about that data set. We just want to use the components of the data set to just look at our graphical representation. Okay, so we go back to our code. So BOD, let's view the data by clicking view in bracket BOD so that we see what the data set is like. Okay, so this is the BOD data set, and it just has two variables, which are time and demand, and it has 6 observations. So 2 variables and 6 observations. So this is time and then demand. So we're just going to look at it and see how we can apply those 3 components of the grammar of graphics to look at this data set. So here we have time. Time is a numerical variable, and here we have demand. Demand is also a numerical variable. If we want to do the plotting, and we had previously said that a single numerical variable can be represented by either what? Either a histogram, box plot, or a density plot. So we're just going to apply that here and see. Let me just write out the coding myself so that you appreciate what I'm doing. So since we said the 3 components, so ggplot is the function that you use. This ggplot is gotten from a package called gg. Let me write it here. It's gotten from a package called ggplot2, and this package is also within the tidyverse group of packages. So because we've installed tidyverse, we also have this ggplot installed on our system already. So we start with ggplot. So ggplot, we said we tell R what data we are working on. So we tell our data is equal to, we started working on BOD, right? It's already there. Fine. Then comma. So we can continue typing on this same line, but to really appreciate, to make it neater and easy to read, we press enter and go to the next line. So we said the next component was what? Mapping equal to, mapping equal to. Now we add AES, aesthetics. So when you do mapping, you always use mapping with this aesthetics. And then we said that aesthetics, the mapping is just defining the coordinate space or the canvas on which we will place our graph on. So now when you do mapping, you tell in mapping, you tell R what the x-axis will be, what your y-axis will be, and then other components if need be. So here we want to look at, let's look at our BOD again. Let's look at the demand here. So we go back to our code and say aesthetic. So it will be X equal to demand, right? And Y. So let's just go to the next line. So there's nita, Y equal to time. So we're telling R that we want demand to be on the X axis. Oh, sorry. X is usually the independent variable. So that will be time. And Y is the dependent variable, and that will be demand. So what we've said in this place now is ggplot. We tell R what data we're working on, which is BOD. Next step is mapping equal to aesthetics. Aesthetics is always used in combination with mapping. And then in brackets, we tell R what we want on our x-axis, which is time. And we tell R what we want on our y-axis, which is demand. Now, the third step will be the geometry. But if I click on Control Enter at this stage, let's see what it's going to show us. Very excellent. So if you look, let me zoom this. No, I want to see the plots. The sheet 3. Sheet 3. Now, if we look at this canvas or this coordinate space, we can see that it has mapped time. It has mapped time on the x-axis. It has mapped demand on the y-axis. So this is what I call the coordinate space or the canvas. And it has put in the scaling for the demand side. It has also put in the scaling for the time side. So, but you can see this is just a canvas. We don't have a graphical representation on it yet. We don't have a bar chart or a histogram on it. So this is what we call mapping. So if we go back to our code, Control Shift. What's the problem? Control Shift. What's happening? It's not responding. Control Shift 0. Okay, fine. Go back to our code. Okay, so this is where we stopped in the mapping place. So we can appreciate what mapping is right now. So write plus. Now, if you notice, if this was, if we're doing a tidyverse function, here would have been our pipe operator, which is this sign, but this is now ggplot, and ggplot uses the plus sign to say and then, so it will be plus sign here. And then we go to the next, and then we put in our geometry. So it's going to be geom. So this is where we select what type of graphical representation we want. So this, we use two numerical variables in this place. And we said that for two numerical variables, if we look at this place, for two numerical variables, we use a scatter plot. So our geom is going to be scatter, is going to be points. So we select geom points. And then, so if you look at this, those three components of the grammar of graphics I told you about, number one is data, which I've highlighted. Number two is mapping, which I've highlighted. Number three is the geometry, which I've highlighted. So these are the three components of the grammar of graphics. So if we click Control Enter here, so if I look at this, you can see in the plot space, you can see it has plotted points 1, 2, 3, 4, 5, 6 of the demand and time plot. So this is a scatter plot that it has done, but we can add another component to it so that we can actually see the line. We use plus, and then we do another geometry, geom line, and then we click Control Enter. You can see now it has put in a beautiful line to join all the dots together. So that is the geometry part of those components of the grammar of graphics. Now we can add some components into this place so as to make this graph a bit more beautiful. So what we're going to do is, within this place, we can say for the geom points, the points look a bit smaller, so we can increase the size. Let's say size equal to 3. And then the line, we can say we want the color of the line to be red. And then when I click Control Enter, you can see it has changed the color of the line to red. And we now have bigger points at these places. So this summarily is what the grammar of graphics is. And like I said, once you understand these components of the grammar of graphics, which is the data, the mapping, and the geometry, there is no graphical representation in R that you cannot do. You just need to start adding some other extras to it. But the basics is the data, the mapping, and the geometry. Okay, so do we understand thus far? Can I see either by chart or by hand that we understand what we've done so far? Because I'm going to log us off and then log us on to the next session. Can I see a hand, a chart, whatever thing that can tell me that you've gotten what I'm doing? You understand up to this point? You can unmute yourself so I can hear you.
I think for me, I will still need some, like a review.
Okay, a review of this grammar of graphics, right?
This plot, why do we have
why do we what?
Then, oh, this is echoing too much.
Okay, so you want to know why we use plus?
So when you put, like for example, when you put size equal to 3, is it that you want it to become 3 times bigger than what it was before?
Yes, just to increase the size of those dots.
Okay.
Yes. And then the color red, color equal to red is to change. You know, it was black before, the lines were black. So we change the color of the lines to red, just to